Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have m plus 8 whole square equals to 64, and we solve this problem for all the values of m. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So in the first method we use the nice algebraic formula. Here you know about that. If we have a plus b whole square equals to a square plus 2 times of ab plus b square, so we apply this nice formula into the left hand side of the above equation. So after applying this formula, this term is written as in this form: m square plus 2 times of m into 8 plus 8 square is equals to 64. And now further in the next step we have, this is m square plus 2 times of 8 becomes 16 times of m plus this 8 square becomes 64, and this whole equation is also equals to 64. And now we move the terms 64 from right hand side to the left hand side, so we obtain m square plus 16m plus 64 minus 64, and this whole equation equals to 0. And in the next step we have, this is minus 64, this is plus 64 are cancelled out by each other, and we get the remaining values are m square plus 16m, and this whole equation is equals to 0. And in the next step you see here, both of these two terms involve m, so that we will be take common m from here, and when we take common m we get the remaining values are, from here we get m plus from here we get 16, and this whole equation is equals to 0. And in the next step we divide this equation into the two cases. The first case is we write m is equals to 0, and the second case is we write m plus 16 is equals to 0. This is the first root of the given equation, and from here we move plus 16 to the right hand side and we get m is equals to minus 16. So this is the second root of the given equation. So you see here, from first method we obtain these are the two roots of the given equation, and now in the next steps we need to verify that is these roots be the solution or is these roots be the extraneous root of the given equation. So for verification of this we need to copy down given question statement. Here it is m plus 8 whole square equals to 64. This is the given question statement, and in this side we will be verify m is equals to 0, and in this side we will be verify m is equals to minus 16. So we verify both of these two roots, and now first we focus on m is equals to 0, and we put m equals to 0 into the left hand side and we check its behavior. So when you put it here it will becomes 0 plus 8 whole square equals to 64, and we know about that 0 plus 8 becomes 8 square equals to 64, and we clearly see that we get 64 equals to 64. So this shows that the value m is equals to 0 is satisfied our given question statement. And now in the same pattern we verify the second value of m. Now, so we substitute m is equals to minus 16 into the left hand side, and we obtain minus 16 plus 8 whole square is equals to 64. And further we have minus 16 plus 8 becomes minus 8 whole square equals to 64, and we know that when we take the square of negative term it will always becomes positive. So minus 8 square becomes positive 64 is equals to 64. This again shows that the value of m is equals to minus 16 is satisfied our given question statement. So finally we have we just show that both of the roots are satisfied our given question statement. So finally we have the solution set of given question is m equals to 0 and minus 16. So these are the two solutions of the given equation which we get here from first method. And now in the next step we again solve this problem for second method. So for the second method we need to copy down given question statement here, and the given question statement is m plus 8 whole square is equals to 64. This is our given question statement, and here we use another technique to solve this problem. Here in the second method we just use the square root technique to solve this problem. So for this we will apply, or we will take square root on both of the sides, and when we take square root it will becomes m plus 8 whole square and its square root is equals to 64 and its whole square root. You very well know about that when we apply square root on both of the sides, we will be right here plus minus sign on any one of the side. But here you see that this 2 and this square root are gone, and we get m plus 8 equals to, here we know that square root of 64 becomes 8, and here we write plus minus sign. And in the next step we here we need more simplifications in order to get the values of m. We have here you see that the right hand side is positive or negative, so we break it two cases. Here m plus 8 is equals to positive 8, and in this side we have m plus 8 is equals to negative 8. And here further we need more simplifications, and we move plus 8 to the right hand side. We get m is equals to 8 minus 8, and here we clearly get the value of m is equals to 0. This is the first root which we get here from second method, and here similarly we move this plus 8 to the right hand side, and when we move 8 to the right hand side we again get minus 8 and minus 8. And here finally we need to sum up minus 8 and minus 8, and we get minus 8 becomes minus 16. So this is the second root of the given equation which we get here from second method. So finally you see that in the second method we again get the same roots which we get here from first method, and in the first method we already verify that both of these two roots satisfied our given question statement. So finally we have the solution set of the problem which we get here from second method is also m equals to 0 and minus 16. This is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.